Have you ever wondered if there's more to the universe than what we can see and touch? The fourth dimension is a concept that has intrigued scientists, mathematicians, and philosophers for centuries. While we live in a 3D world where we can experience height, width, and depth, the idea of a fourth dimension challenges our perception of reality. Is it real? And if so, can we ever truly understand it? Let's dive into the fascinating science and theories behind the mysterious fourth dimension. To grasp the fourth dimension, let's start with the basics. A 1D object is simply a line, having only length. Add width, and you get a 2D plane, like a piece of paper. Introduce depth, and now you have a 3D object, like a cube. The fourth dimension is a step beyond this, an extra-spatial or temporal dimension that we cannot directly perceive. While it sounds abstract, mathematicians and physicists have developed ways to represent and explore this concept using advanced mathematics and models. Albert Einstein's theory of relativity brought the fourth dimension into the scientific mainstream by proposing that time is the fourth dimension. Together with the three spatial dimensions, time forms what we call the space-time continuum. This model explains how massive objects like planets and stars warp space-time, creating the effect of gravity. According to Einstein, every event in the universe can be described by four coordinates, 3 for space and 1 for time. Because we can't perceive the fourth dimension directly, scientists use analogies to help us imagine it. One common example is the hypercube or tesseract. Just as a 3D cube casts a 2D shadow, a 4D object would cast a 3D shadow in our world. The tesseract is a theoretical representation of how a 4D cube might appear if projected into 3D space. Although it's challenging to visualize, these models help bridge the gap between abstract mathematics and our limited perception. In modern physics, the concept of higher dimensions goes beyond just the fourth. Theories like string theory propose that our universe may have up to 11 dimensions, with most of them being curled up or too small to detect. These extra dimensions could help explain some of the fundamental forces in particles in the universe. Experiments at places like CERN are attempting to uncover evidence of these hidden dimensions, though they remain purely theoretical for now. The fourth dimension isn't just a scientific curiosity, it has inspired countless works of art, literature, and philosophy. From the mind-bending geometry of M.C. Escher's art to the tesseracts featured in science fiction, the idea of higher dimensions fascinates people across disciplines. Philosophically, the fourth dimension raises questions about the nature of reality and our ability to perceive the true structure of the universe. Are we limited by our biology, or is there a way to expand our understanding? While the fourth dimension might seem like a purely theoretical concept, it has practical implications. Understanding space-time has already led to technologies like GPS, which relies on relativity to provide accurate positioning. As science progresses, exploring higher dimensions could unlock new technologies, expand our understanding of the universe, and even lead to revolutionary breakthroughs in travel and communication. So, is the fourth dimension real? While we may not be able to see or touch it, evidence from physics and mathematics strongly suggests its existence. Whether as a temporal dimension or part of a larger multidimensional framework, the fourth dimension offers a tantalizing glimpse into the unknown. It challenges us to think beyond our everyday experiences and opens the door to new possibilities in science and philosophy.